You see here. So whatever you have imported, you are doing it. Or explicitly, you can say like from module 1, I want to import only so E and F. I can go here and write like module 1. So only import E. So similarly for module 2, you want to import like, okay, module 1 has like A, B, C, D, right? So I want to explicitly import so A and B. So A and like B, or like that also I can do. But this is a bit hard. Rather than doing like this, you can do the same things in a much better way. So how to do that in a better way means, so instead of like this explicitly doing by writing these things, at the module level, we can figure what should go. Means in the script, you have this logic like this, right? So the same package I want to take, and I want to take another copy. So maybe like package 2, I want to take. So in the usage, instead of package, I want to take from the package 2. So import, so package 2 I want to do. This time for the package 2 I want to do. So dir of package 2. So this time I'll write the logic slightly different. So instead of doing like this, explicitly writing everything, so we can do in a different way. Here you can say all. Earlier you remember when you did a all, you didn't get it right. That is because of this only. So if I say like, hey, I want module 1, no matter which subdirectory it is part of so and so. Within this directory, there are two Python scripts called as module 1 and module 2. And so like that, I want everything I want. Within the modules, now you write your logic. So earlier, you remember when you executed also, you didn't get. The reason is very simple. So when you're writing this all, every script should have this all within it. In it, I wrote all, right? Instead of direct packaging. In every module, I need to have this all. So here, all where you can control at the script level itself, what you need to expose to outside. Similarly, if I go for module 2, so here also I can explicitly write what I want to expose. So here I want only 2 of them to be exposed. And in module 3, I don't want to expose anything. Okay. So this time I have some things like this. Now I removing this so that it would be easy. Because sometimes if they are there, it would be crazy, or you cannot see all. Now we see here, I came here. So you are somewhere here in this directory and you are asking, hey, package 2, you are asking. So Python uses so and so. In the current directory, there is a package 2. I think I gave the same name, right? Yeah, somehow I didn't understand. Okay, I got the values. And similarly, if I go dir, I got the list of attributes. So whatever are there, I can directly use. So that's it for now. So like this, this is another way of creating package. Now, I told you how to create a package, how to create a module. So like this. Now you take this example and you create some package for doing some operations. So let's see tomorrow more onto it. Just for you to understand, I created it in a separate folder. Again, you can navigate back to from where you started. You can see list of all the files and folders. So what are you have? Turtle is a very small module. If you want to learn Python or like any programming language, they will give some basic things. So I think there is one more language called as Swift, I guess. No, not Swift. There is another language which MIT people have created. I don't remember the exact name, which is also similarly. If for any person, if they are coming to programming newly, if they want to know how to write the logic building better way, this is a good example for them to understand. So what it does, it's nothing. So it will create a UI visualization. Let's say this program is there and I want to execute, say like 00, so and so. First, it will create a turtle and then it will, say UI will come. Did you see now what you are doing right now? First, it created a turtle, means this turtle, and it is moving forward by 50 steps. Then done, that's it. So similarly, if I go for one more example, this time I do the turtle. For the 4 times I am doing, what I am doing, every time moving forward by 50 and I am right turn by 90 degrees. 0, 1, so and so. You see now, 4 times how it is executed. First time 50, next 90 degrees, 50, 90 degrees, 50, 90 degrees, 50, 90 degrees. So like that we created a turtle. Or if I go for a star, so this time you can see the movement much more slowly. You see now how it happened? Each time it is executing, right? See how it is executing? For 20 times it will do. Every time move forward by 50 and right angle by 144. You give different numbers and see how things are working. And similarly, if I go for a hexagon, how it is working. If I go for say Python 03, so and so. You see now, every time it is creating and it is moving the degrees by slightly. So what are the names I create, that doesn't matter. Hope you understood how the logic is happening. The inclination, angle, polygon means multiple sides. So hexagon means like these are fixed sizes. Polygon means any number of sides you want. Instead of like 6 sides, I want like 10 sides. If I give 10 sides right now, so it will do 10 such shifts, right? And the program will just be there. So if you close this turtle, then program execution is completed. If I execute the same turtle again, if I give like 10 times right now, means I want 10 sides. Based upon that angle it is taking. What if I say 22 sides I want? Now if I execute, did you see? It is kind of like creating a big one. So the more the sides you have, it will seem like a circle, right? So the lesser the sides you have, it will seem like you can see the sharp edges. So just to show you. And next one, if you want to draw a spiral, so this is a program, Python 04. So drawing a spiral. You see now, every time I'm splitting, but every time I'm reducing the length. So that's why see, same like a square, but every time I reduce the length. So as I'm doing the reducing the length, so that's what it happens. And similarly, if I do a spiral from outside, there is like, you can go to the program like how it is working and it will work. You see, background, I made something else. Till now, I didn't write the background and others. You can specify the background colors and title and others. So based upon that, whatever you give, it will take. So in the same fashion, not only that, spiral from inside means the same thing in a reverse direction. You see, from inside out, it will go. Means the size I am incrementing. Same like a square, but every time I increment the size. So ultimately, it's all math. So how better you do it? And similarly, this spiral, not only this. So if I say like 07, you see now, I'm creating a spiral like this. So which like all these things, expanding spiral of all these things. So over a period of time, this spiral is creating a new one more dimension for you to understand. And in the same lines, when something is executing, if you stop, it will throw this kind of as exception message. That's fine. So in the same fashion, if I say 09 spiral, I want to do the circular spirals. I made a background color. See the background of black, and I'm giving us a speed also. You can specify the speed also, how much speed it should go. See, I am doing just a squares only. But as I'm doing the squares in a different way, these squares are creating a circle, right? That's what the beauty of math. And similarly, you can do a drawing a triangles and others. I'm just skipping a couple of things so that you can walk through them. So Python, so 010, you can see I'm drawing the circles. A circle with a triangle within a triangle, triangle within a triangle, like that. And similarly, there are some examples. These were not I created it. These are like ready-made, so built-in examples. Wherever you go, you see it. So there is like a Christmas tree. So just true. You see now, this is a good example. I think one of the site has done. So that's why I mentioned their name also. I didn't change so that you'll see. So don't you think it's like a square? Here a rectangle, and here it is a rectangles only. Every time rectangles with the size is decreasing. That's it. And finally it is a star, right? After the star, it is navigating and it's creating a circle. So and within that inner circle with small less, and it is changing the shape of inner one. And the same stars at a different random places it is adding the same stars, so of different sizes. So randomness. So it is all finally a Python program. So with all these things. So don't you think it's interesting?
Yeah, it's a cool.
Yes. So this is a site which was created. So I just made the reference so that you can walk through them. In the same lines, I created like flags. So in Indian flag you can see, or different flags you can see. So how the flag is there. Again, it is three rectangles of different colors. Within that a circle with spikes. So all the spikes you can write. So 24 spikes you write. That's it. You get it. So I wrote like Indian flag, US flag. So all these things are there. So you can do what are patterns you want. I think there were some kind of more examples I've added so that you can just walk through it, like traffic lights, whatnot. Which are examples I found like good. I added all of them so that you can walk through. So that's it about it. Yeah, please go through. That's it.